Welcome, explorers. Are you ready? Because today, we're embarking on a pretty high-stakes expedition into the wild. Our subject? Well, it's one of nature's most fascinating, completely invisible forces. We're going to track it, study its behavior, and most importantly, learn exactly how to master it. Think of this as your cinematic field guide to magnetism. It's an explainer designed specifically to be your ultimate Grade 7 exam prep tool. So let's just dive right into it. To successfully navigate this subject for your exam, we've got a roadmap covering 5 distinct habitats today. First up, what is magnetism? Then, magnets and magnetic fields. Number 3, magnetic versus non-magnetic. 4 is rust and corrosion. And finally, number 5, handling and everyday uses.
All right, Section 1. What is magnetism? Let's set the scene for our first encounter and look at the ancient, almost magical origins of magnetic forces.
So to really understand this force in the wild, we actually need to look at the domestic first. Question 1 asks, why do we use magnets on fridge doors? I mean, it's pretty simple, right? We use them to stick notes, lists, or play with those little plastic letter magnets. But you know, this everyday tool has a really ancient ancestor. Which brings us to question 2. What was discovered thousands of years ago about a certain stone, and what was its name? Well, ancient explorers stumbled upon a stone that naturally attracts iron. They called it lodestone. Now, because this pulling force was totally invisible, it leads to question 3. What did ancient people actually believe about it? Get this, they genuinely believed the stone had magical powers. And finally, question 4. What happened when parts of this stone were brought together? Observers noticed that parts of the lodestone either attracted each other, pulling together, or they repelled each other, pushing completely apart.
Okay, let's strip away that ancient magic and look at the hard science. Question 5 is an absolute must-know for your exam. What is the scientific definition of magnetism? Listen closely. Magnetism is a force that can attract, meaning bring closer, or repel, meaning push away, objects that have magnetic material like iron inside them. In short, it's the ability to attract iron. Seriously, memorize this definition, guys. It's literally the beating heart of our entire expedition today.
Now let's examine the biology of these stones, so to speak. Question 6. What material is actually inside lodestone? It contains a material called magnetite. That's a type of iron oxide, which is basically just a chemical combo of iron and oxygen, which leads perfectly into question 7. Is lodestone natural or artificial? Well, because it comes straight from the earth, it's a completely natural magnet. All right, question 8. What are all magnets actually capable of? It doesn't matter their shape or size, all magnets share one core instinct. They are capable of attracting other magnets or magnetic objects. And lastly for this bit, question 9. What are magnetic objects made of? To be influenced by this force, they've got to be made of iron or some other magnetic material. Moving right along to section 2, magnets and magnetic fields. We're crossing into new territory here to track the invisible footprints these forces leave behind.
Let's start this section with a fundamental mystery. Question 10. Why do magnets attract certain objects? Take a split second to think about that. It happens because those objects have wandered into the magnet's territory. Scientifically speaking, they are placed inside a magnetic field, or they have a magnetic field around them. Think of the field as this invisible web of power the magnet casts out.
Out in the wild, we see 2 very different types of behaviors. Let's look at question 11. What is a temporary magnet and how does it work? A temporary magnet is something like a paperclip. It only acts like a magnet while it's physically inside a permanent magnet's field. The second it steps out of that field, it loses its magnetic power incredibly fast. So, for question 12, what exactly is the difference between a permanent and a temporary magnet? Well, a permanent magnet keeps its magnetic properties for a really long time, whereas temporary magnets are just brief visitors. They lose their power fast when they're removed from the magnetic field.
Let's classify these permanent residents. Question 13 asks, what 2 types of permanent magnets do we get based on how they're made? We've got natural permanent magnets, like our old friend lodestone, and artificial permanent magnets, which are man-made. Now let's look at their anatomy for question 14. What 2 poles does a magnet have? Simple. Every single magnet has a north pole and a south pole. For question 15, can you name and describe the 2 basic shapes you use in class? First, we have bar magnets. These are rectangular, with the north and south poles resting far apart at opposite ends. Second, we have horseshoe magnets. The bar is bent like a horse's hoof, which forces the north and south poles to sit much closer together.
Now, let's watch them interact. Question 16. What happens when bringing specific poles together?
If you bring a north to a north, they repel. A south to a south, they repel. But a north to a south, boom, they attract. This brings us to question 17, which is perhaps the most critical law of the magnetic jungle. What is the golden rule of magnetism for poles? Like poles repel and opposite poles attract. To clarify that motion for question 18, what are repulsive and attractive forces? Repulsive forces push objects away from each other, while attractive forces pull objects together.
When you're sitting in the exam room, you're definitely going to need to map these fields out. So, question 19. Which two important rules must you remember when drawing magnetic fields? Rule number 1. The magnetic field always moves from the North Pole to the South Pole, and you have to indicate this direction with arrows. Rule number 2. Magnetic field lines never ever cross each other. Stick to these two unbreakable rules of tracking, and you'll secure those marks for sure.
All right, on to section 3, magnetic versus non-magnetic. Here, we're going to observe which materials react to this invisible force and which ones just totally ignore it.
Pay really close attention here. Question 20. Can you name the 4 magnetic metals? You absolutely must memorize the big 4: iron, nickel, cobalt, and steel. But wait, question 21 poses a bit of a riddle. Why is steel magnetic? I mean, steel isn't a natural element on the periodic table, right? It's magnetic because steel is actually an alloy that contains iron, and where there's iron, the magnetic force is going to find it.
But what about everything else? Question 22 asks, are brass trumpets, gold, plastic, zinc plates, wood, and aluminum window frames magnetic? The answer is a hard no. They are all completely non-magnetic. They just ignore the magnetic field entirely. Now, question 23 exposes a brilliant little disguise. Is a tin can magnetic? Explain. Okay, the answer is tricky. No, tin itself is not magnetic. So why on earth does a magnet stick to a tin can? It's because a food can is actually made of a very thin layer of steel, and it's just coated in tin to stop it from rusting. The magnet is attracting the steel inside, completely ignoring the tin disguise on the outside.
Speaking of rust, that brings us right to section 4, rust and corrosion. Let's see how these powerful iron-based materials survive against the harsh elements of nature over time.
You see, oxygen is kind of like a slow, silent predator to our magnetic metals. Question 24. What is corrosion or rust, and how does it form? As soon as a metal like iron or steel comes into contact with oxygen, it forms rust over a period of time. But here's a super fascinating fact for question 25. Is rusted iron still magnetic? Actually, yes. Even heavily rusted iron keeps its magnetic spirit alive. So for question 26, why do we use tin and zinc to protect iron and steel? Well, we use them like armor. Because tin and zinc do not rust easily. They shield the vulnerable iron underneath from the oxygen.
And here we are at our final section, number 5, handling and everyday uses. Now that we understand these wild magnetic forces, how do we safely domesticate them in our daily lives?
Magnets are incredibly powerful, but they can be destroyed so easily if you don't treat them with respect. Look closely at question 27. Which 4 things must you never do with magnets to avoid damaging them? First, never store them with the same poles facing each other. Second, never bring them near a fire or a flame. Extreme heat literally kills magnetism. Third, never drop them. And fourth, never hit them against something. Violent shocks scramble their internal structure, causing them to lose all their power.
Now, because horseshoe magnets have their poles so close together, they need special care in captivity. Question 28, how should a horseshoe magnet always be stored? The answer is that it must always be stored with a specific survival tool called a keeper. This keeper bridges the gap across its ends to protect its poles and preserve its magnetic field while it rests.
And finally, question 29. Can you name 8 examples of where we find magnets in our daily lives? Now that you know what to look for, you're going to spot these captured forces everywhere. You'll see them as fridge magnets, in the ceiling strips on fridge doors, inside loudspeakers, and in compasses guiding our way. You'll also find them hidden in the magnetic strips on your bank cards, powering electronic door locks, spinning electric motors, and even in massive industrial cranes lifting heavy scrap metal. Guys, you are now fully equipped with the knowledge to totally conquer your science exam. The invisible world of magnetism is no longer a mystery to you. So I'll leave you with this. When you look around your home today, how many more hidden magnetic forces can you spot? Good luck, explorers, and happy studying!